Hello, and welcome to the Advancing Mainframe Modernization with Slingshot and Microsoft, the session brought to you by Publicis Sapient. I'm John Weston, Vice President of our Microsoft practice here at Publicis Sapient, and today I'm joined by Thanu. Thanu, you want to do a quick introduction?
Thanks, John. Hi, I'm Thanumoorthy Sundaresan, Vice President Engineering. I'm also the solution lead for generative AI-based mainframe modernization.
Great. Well, I appreciate everyone joining us today. What we want to talk to you about a little bit is a solution that we've got called Slingshot. One of the things Slingshot can do is help you get out of that legacy debt. How many people have old COBOL systems, mainframes out there, AS400s, or all kinds of other old legacy applications that are just holding you back from modernization? We have a very unique approach here to be able to help transform that information into cloud-native solutions and get rid of that legacy debt much more efficiently in the past. And the way we do that is using Microsoft's AI. Specifically, Slingshot runs on top of Azure OpenAI to be able to help you much more efficiently transition out of the legacy debt into something more modern. What we're going to talk about today is to show you a solution where we took a US healthcare provider and that had tens of thousands of COBOL screens on a mainframe. And what we wanted to do is help them modernize that. And what we do with Slingshot is we use Slingshot to go read that old COBOL code, instead of just translating it into modern code, if you will, and you leave all the old legacy data structures and code structures just in a new syntax. We take a totally different approach. What we do is we go from code, from COBOL, to a design document. We then take that design document, work with the business to help figure out, is this really what you want your solution to do? We modify that design document, then we send that design document a second time back through Slingshot on top of Azure and create code out of that. What that allows us to do is be able to get rid of all the old legacy data structures, the legacy code structure, and have truly native containerized code in the cloud once we're finished. Okay, and this allows us to do this much more efficiently using AI. We couldn't do this before AI because it obviously would take way too many man hours to be able to do it. But today it's much more efficient to be able to do that. So now let me turn it over to Thanu to show us exactly how we do this with a demo.
Thank you, John. Thanks for the opportunity.
John mentioned we break our process into two steps. First one is called code to specification and design, and the second one is called specification to code. Code to specification to design, or code to specification as we shortly call it, is meant to extract the business logic from the legacy code in various formats. I'm going to demo this process to you now. I already provided the input that I need to execute this process. I'm just going to upload the file. So this is a zip file that I'm going to upload. It has one single COBOL file. You can upload a zip file with multiple COBOL files as well. Once I do it, I'm going to execute the process now. You'll see that, starting with file upload, it goes through a series of steps, eventually resulting in a creation of a behavior-driven development document, which is nothing but use stories in the Gherkin's formats, given, when, then, and format. So each of the steps are exposed as FastAPIs, and behind the FastAPIs, we have our agents and the prompts, which sits on top of LLMs, and the LLMs are configurable. We can pick and choose the LLM that we want. This entire process runs in Azure Kubernetes and sits on top of Azure AI Studio. Okay, let me walk you through some of the artifacts that are created. Before I go there, one thing that I do want to mention is that the various stages that you see here result in a distinct set of artifacts. The idea of the steps is to ensure that as we progress through the steps, you iteratively remove all the technical implementation detail from the code, so that the final output, which is the BDD that comes out, contains only the business logic that the COBOL code represents. So the flowchart that we create is quite detailed in nature. So we start typically with an overview diagram, and then we go into each steps, each process within the COBOL code, a lot more in detail. So this helps us in a couple of things. One is If there are any issues that we see as part of the conversions, a non-COBOL technical engineer can basically go back and check. Let me first walk you through the COBOL code that I just uploaded. It manages inventory details, course inventory details of an university. So you can upload a set of courses to that university, and this COBOL process program, what it does is looks at the courses, runs it through a set of validations and some business rules, and provides a report which says which other courses are approved as part of this university's curriculum for that particular term. So like typical COBOL code, it has the usual initialization sessions, environment section, data divisions, where most of the data structures are defined, and also it has reference to copy books. And typically around, if you look at it, this COBOL code around the line 3000 is when the actual business logic implementation starts. So there's various subsections. It kind of continues all the way till the line 6000, and then it kind of closes with the finalization, where it actually creates a output file. So with this as the input, let me show you the set of artifacts that we create as part of the code to specification process. One of the first things that we create, as I mentioned previously, is the set of flow diagrams. We do create a high-level flow diagram which explains the entire high-level view of the flow of this particular COBOL code, starting with the various sections that are there in the COBOL code, and at a very high level what each of the sections do, and eventually it kind of follows it to the actual execution of the business logic, and it kind of details those sections as well. For you to have a quick look at it and see what this program actually does, then each of the sections are in turn detailed into separate flowcharts on their own. So, for example, if you look at the finalization section, it kind of details quite almost the line-by-line basis on what each of this, what is the execution of logic of the finalization flow looks like. Okay. Now we also create technical specifications. These are almost pseudocode-ish representation of what the COBOL code does. The flow diagram and this technical specifications are used by our non-COBOL developers to come in and have a look at it and understand the business logic if they have to. Typically, if we see any issues in the generated code, we come back and have a look at the business logic, the original business logic, to see that there is something that is missed as part of the translation. So it's used for troubleshooting. This is also an output that we provide to our clients, so they can have a look at in detail if they want to all the implementation details of their legacy code. And this also has kind of a high-level section, and then each of the sections are in turn broken down into further subsections. So each of them have their own detailed description in a pseudocode language on what they do. Okay, and the final output that we create is the VDD. This is the technology agnostic way of explaining what the program that we just inputted does. This is also used to act as an input to our next stage, which we call as specification to code, and that's where we use this as an input and create our the to-be code. In this case, we are going to create a Java code. Okay, and this is used. Typically, we use this not just as an input for our code, but also input for our test cases. And this is also something that we give it to our clients as an output, which they can review. So let me go back to the demo program, and then let me run the code to spec process. So there are two inputs that I give. One is a configuration, which basically gives details on how this application should execute. There are various input parameters. Now let me walk you through the specification to code part of the process. This process takes two inputs. One is a config file. This is the configuration that this process uses. So let me upload it. And then the second input that we provide is the BDD files that we have created as part of the previous process, which is code to specifications. So again, zip format. So when that is done, let me start the process. So it started generating the code. While this is happening, I'll show you how the converted code looks like. As you can see, the COBOL code, a single COBOL file, which had about 7,000 lines of code, with multiple logical sections under it, has been broken down into multiple services, broken down on domain boundaries. So there is a service for managing the inventory, service for doing the validations, etc. And the code that is created is also of microservice quality, as you can see. One of the examples I want to highlight it is, if you look at it, we have introduced a batch. Process also creates test fields. So we create feature definitions, and then we automate them so that this test fields can be executed against the compiled code, and the reports can be visualized. Thank you.
Thanks, Thanu, for that demo. That's a great way to show in person how our information allows us to be able to use Slingshot to help you get out of that legacy debt. If you'd like to find out more information about how to help your company get this done, come by our booth if you're here in person at Ignite at booth 5226, or go to our website at publicissapient.com/sapient-AI solutions and allow you to be able to take a look at how we were doing this in the real world for other customers. Thank you again for joining our session.